memory storage. We've seen reasoning getting better in the past years. No memory. Why? LLMs forget everything. They're stateless. There's no memory between sessions, and all your preferences, decision when you've reached the new conversation, they are all gone. Context limits. I'm sure many of you have reached a long conversation, chatting days, ages. The messages get out, right? So you hit the token limit. What some companies have done is just summarize the context and go on, but information still gets lost. We need a simple and smart way to have memory. And that's where OpenClaw's approach comes in. Files are the source of truth for OpenClaw, especially markdown files. They are human readable, you can access them, you can edit them, and they are not created with any LLM code. You have maybe, yes, it was said before, you have daily logs and long-term logs. Daily logs for daily notes and just quick ideas. And whenever you start a new session, today's and yesterday's daily notes are inputted as context. For long-term memory, that's what's really important. You can either input yourself some preferences, I like cappuccino, or my name is Alicia, or I work at Process. You can put that in your markdown file, but what's going to happen, the agent is going to grab all of the sessions, all the conversation, is going to decide which is the information that you actually always need, that it's part of you, right? How do we retrieve memory, actually? OpenClaw does it in a very, very simple way, through hybrid search. You have semantic matching, so you can use similarity between embeddings to see the meanings of different parts of the word, which have different complexity. And then keyword matching, if you need a specific name, a specific date to be retrieved, right? Just put them together, do the best of both worlds, do it hybrid. Here OpenClaw does it 70% vector-based, 30% text form. Let's see how it works. Hopefully my demo works. We can switch to my laptop, I think. Nice. Okay, we're gonna open Claw on board very fast. There you go. I'm gonna set up my API key very fast. You don't need any channels right now. And skills, what you need is to enable the hooks. I'm sure whoever used OpenClaw did it. You just have to select session memory, and then all the session context is gonna be used. There we go. It's gonna take 1 second to start, as you know, and what we're gonna do is we're gonna give it some information, we're gonna see where this information is stored, and when we have a new session, hopefully, how this information is retrieved. Okay, almost ready. So yeah, this is pretty easy compared to all other companies so far. Even Anthropic, they have this memory system, but it's not an empty file that you can just access, change, you know? There you go. Okay, so we can say that I have a memory agent presentation this Thursday, which is today, right now. And then in a different prompt, we can give it some more information, saying 7:30 p.m. is my presentation. We're a bit late on schedule. That was the initial time. Now, what this is going to do is going to hopefully take some information and create a new markdown file for the day of today with this information. Now I'm going to give some more different details. I love the Topium Blend coffee at a specific place in Amsterdam. And that's also going to go into daily memory. Let's look at the long-term memory for a second. Now, it lives here into memory empty. You can populate it yourself, again, with the information that you really need the agent to always remember. Here's what I wrote. Oh, okay. I'm already put it here. Nice. But as I mentioned, you go throughout the sessions, the conversation. The agent knows which information is just daily noise and what is actually needed. So you can see here that information was written into a markdown file from 12th February 2026 today. And also, it recognized that I love a cup of coffee. It's a long-term memory. What we're going to do now is we're going to start a new session, so it doesn't take the context of the conversation I'm having right now. And I'm going to ask how to retrieve this information, and hopefully which is very easy. Takes a second, of course, to start a new session, but let me walk you through different types of retrieval that you can have. You can have retrieval of factual text, so dates, events, whatever. That is single hop, so you retrieve from a single prompt. Whereas you can have multi-hop retrieval, where you say you inputted information from multiple prompts far ahead in the conversation. What OpenClaw really shines is in retrieving that information from different parts of the conversation and being able to put them together. Then, of course, you have temporal retrieval. Let's ask this question. What do I have coming out this Thursday? Hopefully, it's gonna work. Okay. Next question we can ask, let's say, where do I work? I'm sure you've seen it, but you've got a memory representation scheduled for Thursday, 7:30 p.m., and the source is the memory file. Great. We can actually access the memory file. We can actually see it. It lives on your disk. There you go. In terms of security, that's better, but there's still prompt injection process. So that's an ongoing problem. Where do I work? This is now is going to take it from long-term memory. It's searched from the memory which is long-term. Perfect. It works. We can go back to the slides for the presentation. And as I mentioned, there are 3 types of memory recall that I've shown here. We have factual recall, so just retrieval of an information. I have an event on Thursday, great. Multi-hop recall, which again is where OpenClaw shines. We have separate messages, and what it does, it just puts them together. It does cross-fact synthesis, and it's able to retrieve the information and provide it together. And temporal recall, so you've seen that I mentioned just Thursday. What it did, it read the name of the file, and it understood, well, Thursday, 12th February. Also able to do that. It's fast, accurate, and efficient. Why? Here is just a small evaluation compared to other memory implementations on a benchmark for long context, very, very long context Q&A conversations. It shines in accuracy, but what's really interesting here is that there are no LLM calls for memory creation compared to other implementations. So you just create this markdown file. Of course, there's an LLM call for just the query and the answer, but compared to other implementations which have a lot of LLM calls, it's much, much cheaper. And per question, there's 1 up to 2, let's say, yeah, 3.6 less fewer calls to the LLM per query. That is why other implementations are much slower, and what they do is they call an LLM just to summarize the context and then compact it and then find some information. This is just does it with simple RAG. That's it. Thank you.